Hello, my name is Daniel, and today we will be going through the AMC 10A from the year 2017. So let's get started. First problem: what is the value of this? So let's just do everything step by step. So this is 3. So 3 and 3 times 2, this would be 6. 6 plus 1, that would be 7. 7 times 2, that would be 14. 14 plus 1 is 14 plus 1, that would be 15. 15 times 2 is 30. 30 plus 1 is 31. 31 times 2 is 62. 62 plus 1 is 63. 63 times 2 is 126. 126 plus 1 is 127, so the answer is C. Number 2, Pablo buys popsicles for his friends. The store sells single popsicles for $1 each, 3 popsicle boxes for $2 each, and 5 popsicle boxes for $3 each. What is the greatest number of popsicles that Pablo can buy with $8? Okay, so obviously the best deal is when you're buying more popsicles, right? So our best deal is when the $8 are divided into $3, and $2, right? And so this gives us 5, this gives us 5, and this gives us 3. And so we have 5 plus 5 plus 3, which is 13. The answer is D. Number 3, Tamara has 3 rows of 2 6 feet by 2 feet flower beds in her garden. The beds are separated and are also surrounded by 1 foot wide walkways as shown in the diagram. What is the total area of the walkways in square feet? Okay, so we want the area of these walkways that are in between, right? And to get that, we can just have the total area of the whole thing, and we can subtract 6 of these small flower beds, right? And so to get that, first of all, the wide whole thing, this is 6 feet. Sorry, this is 6 feet by 2 feet. Same thing for here, 6 feet by 2 feet and 2 feet and 2 feet, right? And so the whole thing is going to be this is 16161, so that will make it 15. So this is 15, and then this is 1212121, right? And so that gives us 3 times 3 plus 1, so that is 10. That's 10. And so 15 times 10, which is 150, and 6 times the flower beds, right? So 6 times the flower beds, and each flower bed is 6 and 2, right? So this is 6 times 6 times 2. This is 36 times 2. This is, sorry, I forgot to put a 0 at the end. And so this is 72. And so the total area of the walkways is 150 minus 72, and this equals 78. So the answer is B. Number 4, Mia is helping her mom pick up 30 toys that are strewn on the floor. Mia's mom manages to put 3 toys into the toy box every 30 seconds, but each time immediately after those 30 seconds have elapsed, Mia takes 2 toys out of the box. How much time in minutes will it take Mia and her mom to put all 30 toys into the box for the first time? So this is right between the mom between the mom putting in 3 and Mia taking out 2, right? And so right at this moment in time, right? And so that means we need a first 30 seconds to have elapsed. Yeah, so this 30 seconds will have been for the 3 toys that Mia's mom put in, and we need 30 seconds times n more times for one toy, one toy being put into the toy box, right? Because after Mia's mom does this, then Mia takes out 2, and so that will be 1 toy for each 30 seconds, right? And their total is 30 toys, right? And so to make 3 toys plus n number of 1 toys be 30, then obviously n is 27, and so this is 27. This is n is 27, right? And so we need 30 seconds times 1 from this plus 27 from this, right? And so this is 30 times 28, so this is 60 times 14, and this is all in seconds, right? Seconds, this is seconds, and since 60 seconds is 1 minute, this is 14 minutes, right? So the answer is B. Number 5, the sum of 2 non-zero real numbers is 4 times their product. What is the sum of the reciprocals of the 2 numbers? Okay, so let's say that the non-zero real numbers are A and B, so their sum is 4 times their product, and we need the reciprocals of the 2 numbers, the sum, right? So it's 1 over A plus 1 over B. and 1 over a plus 1 over b equals a plus b over ab. And so what we want is to divide by ab, so this will be ab, and that is exactly what we need. So the answer is 4, it's C. Number 6, Miss Carroll promised that anyone who got all the multiple choices questions right on the upcoming exam would receive an A on the exam. Which of these statements necessarily follows logically? Okay, so if something happened, then something happened, right? And so what did Miss Carroll promise? If MCQ 100%, MCQ means multiple choice questions, equals then A, right? And so what follows logically is if not A, so if not A, then not MCQ 100%, right? So this is what would logically follow, right? So if this is true, then this is also true. So we have to find the answer choice that says this, and that is if Lewis did not receive an A, then he got at least one of the multiple choice questions wrong, so not 100%. So the answer is B. Number 7, Jerry and Sylvia wanted to go from the southwest corner of a square field to the northeast corner. Jerry walked due east and then due north to reach the goal, but Sylvia headed northeast and reached the goal walking in a straight line. Which of the following is closest to how much shorter Sylvia's trip was compared to Jerry's trip? Okay, so we have a square field, and Jerry and Sylvia wanted to go from here to here, right? And so Jerry went like this, and Sylvia went like this. And so how much shorter Sylvia's trip was? Okay, so let's say that the length was 1, and let's say that the length was 1 and 1, and so this would be root 2, right? And so how much shorter Sylvia's trip was? That would be 2 minus root 2 over root 2. Over 2, right? Because Jerry walked 2 and Sylvia walked root 2, and so how much shorter it was would be 2 minus root 2 and all over root 2, right? And we know that root 2 equals 1.414 something, right? And if you don't know this, you have to know this to answer this question, so memorize it. And so let's say that root 2 is something like 1.4, right? This is 2 minus 1.4 over 2. This is 0.6 over 2, which is 0.3 over 1. And so this is 0.3, right? So Sylvia's trip was 0.3%. So Sylvia's trip was 0.3 shorter than Jerry's trip, and 0.3 equals 0.30. Right, so this is 30%. So the answer is A. Problem number 8. At a gathering of 30 people, there are 20 people who all know each other and 10 people who know no one. People who know each other hug, and people who do not know each other shake hands. How many handshakes occur? So we have 20 people who know each other and 10 people who don't know anybody. And so how many handshakes occur? So between the 10 people, that would be just 10 choose 2, right? And then between the 10 people and the 20 people who know each other, that would be each person from the 10% would shake everybody's hand from the 20 people, right? So that is 10 times 20, right? And so this one is 10 choose 2, which is 45. 10 times 20 is 200. So you add them together, you get 245. The answer is B. Number 9, Minnie rides on a flat road at 20 kilometers per hour, downhill at 30 kilometers per hour, and uphill at 5 kilometers per hour. Penny rides on a flat road at 30 kph, downhill at 40 kph, and uphill at 10 kph. So Minnie goes from town A to town B, a distance of 10 kilometers, all uphill, then from town B to town C, a distance of 15 kilometers, all downhill, then back to town A, a distance of 20 kilometers on the flat. Penny goes the other way around using the same route. How many more minutes does it take Minnie to complete the 45-kilometer ride than it takes Penny? Okay, so first let's construct this route. So we have A, B, C, right? And so from A to B, this is A to B is 10 kilometers, and B to C, this is 15 kilometers, and A to C, this is 20 kilometers, right? And so first, Minnie's time. Minnie goes flat at 20 kilometers per hour, and downhill at 30 kilometers per hour, and uphill at 5 kilometers per hour. Time is distance over speed, so this took 1 hour, and this took half hour, and this took 2 hours, right? And so, yeah, let's write that in red. So 1 hour for the flat, half hour for the downhill, and 2 hours for the uphill. Right, and so this is 7/2 hours, right? And for Penny, Penny will have different speeds, right? And she is also going the other way around. And so for Penny, this will be uphill and this will be downhill, right? And so Penny goes the other way around, and Penny rides on a flat road at 30 kilometers per hour. Penny goes at 30 kilometers per hour downhill, and so this is downhill, right? Downhill at 40 kilometers per hour, and uphill at 10 kilometers per hour, right? And so Penny, 2/3 hours on the flat, and 3/2 hours uphill, and 1/4 hours downhill, right? This is 29/12, right? 29/12 hours, and so it says how many more minutes does it take Minnie to complete the 45-kilometer ride than it takes Penny, right? And so 7/2 hours, 7/2 hours, this equals 210 minutes, and 29/12 hours, this equals 145 minutes, right? And so the difference between these two is 210 minus 145, which is 65. So the answer is 65, it's C. Number 10, Joy has 30 thin rods, one of each every integer length from 1 centimeter through 30 centimeters. She places the rods with lengths 3 centimeters, 7 centimeters, and 15 centimeters on a table. She then wants to choose a fourth rod that she can put with these three to form a quadrilateral with positive area. How many of the remaining rods can she choose as the fourth rod? Okay, so Joy has 30 rods, and she has 3, 7, and 15 already, right? And then she wants to choose a fourth rod, and so we need the lowest value of the fourth rod, so the smallest length, and the shortest length, the shortest length possible to make this positive area, and the longest length possible to make this a positive area, right? And so for the shortest length, then 15 will have to be the longest, right? And so we have 15, and we will have 33, 7, and we will have something. And 3 plus 7 plus this something must always be greater than 15. And so the least value that can do that is 6. So the shortest length is 6. And the longest length, if that's the longest length, then the unknown length will be the longest, and 3, 7, and 15 will be right here, right? And so x, which is the longest length, has to be less than 3 plus 7 plus 15, right? And so x has to be less than 25, so x would be 24 at most, right? So the longest length is 24. And so how many of the remaining rods can she choose as the fourth rod, right? And so that is 24 minus 6 plus 1, because including both including both 6 and 24, right? And so we have to do plus 1. But then we have to do minus 2, because 7 and 15 are in this interval, right? So we have to subtract 2 for 7 and 15, because we can't choose 7 or 15, right? And so 24 minus 6 plus 1 minus 2, this equals 24 minus 7, which is 17. So the answer is B. Number 11, the region consisting of all points in three-dimensional space within 3 units of line segment AB has volume 216 pi. What is the length AB? Okay, so first let's draw AB. And so this would be what AB looks like, right? But then if we have all points in the three-dimensional space within 3 units of line segment AB, then that would be something like this. And so this is the points where it's within 3 units of line segment AB, and so this is 3, this is 3, and right here it's also 3, right? And so if you see, this is made up of one cylinder plus a half sphere plus another half sphere, right? And also if you see, then this would be 3, and the radius would all be 3, right? And so for the cylinder, the volume will be, the base is 3 squared pi, so that's 9 pi times AB, right? So AB is length AB, so that's what we want. Let's say it's x, right? And then for the spheres, combining two half spheres just makes one a full sphere, right? So that's 4 over 3 pi r cubed, so pi times 3 cubed. This is 9 times 4. This is 36 pi, right? And so adding these together, that is 9x plus 36 pi. And so 9x plus 36 pi equals 216 pi, right? And so we can take out the pi here, and we can divide by 9 also, right? And so that will give us x plus 4. X plus 4 will equal 24, right? And so x equals 20. So the length AB, that was x. The answer is 20. It's D. Number 12, let S be a set of points x, y in the coordinate plane such that two of three quantities, 3x plus 2 and y minus 4 are equal, and the third of the three quantities is no greater than this common value. Which of the following is a correct description for S? Okay, so first let's say 3 equals x plus 2 and y minus 4 is less than or equal to 3, right? And so this would be x equals 1 and y is less than or equal to 7. And second, what if 3 is equal to y minus 4? 3 equals y minus 4. X plus 2 is then would be less than or equal to 3, right? And so y equals 7. X is less than or equal to 1. That would be our second. And our last is when x plus 2 equals y minus 4. And so and x plus 2 is less than or equal to 3. Y minus 4 is less than or equal to 3. So x comma y, yeah, so x is less than or equal to 1 and y is less than or equal to 7, and this gives us y equals x plus 6, right? And so if we graph it, then that gives us so we have the value 1 comma 7, right? And so that is the central point that we have. And for x equals 1 and y is less than or equal to 7, that's this, right? That's this line over here. And y is 7, x is less than or equal to 1, that's this horizontal line. And y equals x plus 6, that would be something like this, like that, right? And this would be 6, right? Because the y-intercept is 6. And so this keep going like that and going forever. And so these are three rays with a common endpoint. The answer is E. Number 13, define a sequence recursively by f0 equals 0, f1 equals 1, and fn equals the remainder when fn minus 1 plus fn minus 2 is divided by 3 for all n is greater than or equal to 2. Thus, the sequence starts 0, 1, 1, 2, 0, 2, and so on. What is this much? And so let's just try and write out these f values, right? So f0 is 1, 1, 1, 2, 0, 2. It gave us this. And then the next is the remainder when the previous two values sum is divided by 3. So 0 plus 2 divided by 3 has remainder 2, and so this is 1, and 2 plus 1 divided by 3 has remainder 0, 1 plus 0 divided by 3 has remainder 1, and 1, 2, 0. And so now we see that there's a pattern. So we have 0, 1, 1, 2, 0, 2, 2, 1, and then 0, 1, 1, 2, it starts all over again, right? And so this is cyclic, right? And repeats for every 8, right? 8 terms. Luckily this is asking us F 2017 all the way to F 2024, and that is exactly 8 terms, right? And so no matter which location F 2007 starts at, whether it's at 0, 1, or 2, right, that doesn't matter because it's the sum of 8 consecutive F values, right? And so their sum will all be equal to 0 plus 1 plus 1 plus 2 plus 0 plus 2 plus 2 plus 1. And so this sum equals 4 plus 5, which is 9, and so the answer is 9. It's D. Number 14. Every week, Roger pays for a movie ticket and a soda out of his allowance. Last week, Roger's allowance was $8. The cost of his movie ticket was 20% of the difference between A and the cost of his soda, while the cost of his soda was 5% of the difference between A and the cost of his movie ticket. To the nearest whole percent, what fraction of A did Roger pay for his movie ticket and soda? Okay, so let's say that the cost for the movie ticket is M and the cost for the soda is S, right? And the cost of his movie ticket was 20%, so 1 over 5 of the difference between A and the cost of his soda. And the soda was 5% of the difference between A and the cost of his movie ticket, right? And so we have and so we have two, and so we have two of these equations. So this gives us that multiplying by 5 on both sides, 5m equals a minus s, and 20s equals a minus m, right? Multiplying by 20 on both sides, like that. And so, what fraction of a did Roger pay for his movie ticket and soda? This gives us a equals 5m plus s, and this goes a equals m plus 20s, right? And so 5m plus s equals m plus 20s, 4m equals 19s. And so let's and so it would make sense if m were to be 19 and s were to be 4, right? And so if we plug m is 19 and s is 4 into this equation, then that gives us a equals 5 times m, which is 19, so that is 95 plus s, which is 4, and so a equals 99, right? So a equals 99, and what fraction of a did Roger pay for his movie ticket and soda? And so the whole cost of the movie ticket and soda was 19 plus 4, which was 23, and a is 99, so it's 23 over 99. This is very close to 23 over 100, right? So it's 0.23, it's 23%, so the answer is D. Number 15, Chloe chooses a real number uniformly at random from the interval 0, 2017. Independently, Lawrence chooses a real number uniformly at random from the interval 0, 4034. What is the probability that Lawrence's number is greater than Chloe's number? Assume that they cannot be equal, right? So for this, let's make it kind of geometric, right? And so let's make some axes. Let's make some axes like this, and then let's say that this is the number that Chloe picked, and let's say that this is the number that Lawrence picked, right? Chloe and Lawrence, okay? And so Chloe can choose from 0, 2017, right? And Lawrence can choose from 0 to 4034, which is 2 times 2017, right? And so this is all of the choices that they can both make. And it said, what is the probability that Lawrence's number is greater than Chloe's number, right? And so let's try and draw y equals x, or in this case, L equals c, right? So this is L equals c, right? L equals c. And so if it is greater than this line, then Lawrence is greater than Chloe's, and if it's lower than this line, then Chloe's is greater than Lawrence. And we want the probability that Lawrence's number is greater than Chloe's number, so we want this probability. So we want this fraction of the area, right? And so what fraction of the whole area is this shaded amount, right? And so since 4034 is 2 times 2017, then the ratios are just like 1 to 2, right? And so if we divide this into like this and this, then that gives us the easy visualization. Out of 4 congruent out of four congruent right triangles, 3 of them are the colored ones, and so we have 3 over 4, and that is the answer. It's C. Problem number 16. There are 10 horses named horse 1, horse 2, all the way to horse 10. They get their names from how many minutes it takes them to run 1 lap around a circular racetrack. Horse K runs 1 lap in exactly K minutes. At time 0, all horses are together at the starting point on the track. The horses start running in the same direction, and they keep running around the circular track at their constant speeds. The least time s is greater than 0 in minutes at which all 10 horses will again simultaneously be at the starting point is s equals 2520. Let t is greater than 0 be the least time in minutes such that at least 5 of the horses are again at the starting point. What is the sum of the digits of t? Okay, so we have horses 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? And so t is the least number with at least 5 with at least 5 factors in 1 to 10, right? And so if we solve for t first, t can't be 6, right? Because that would just have 1, 2, 3, 6. And that's just 4. T can't be 8 because if that were to happen, then it would just be 1, 2, 4, 8. So that would also not be possible. And so t equals 12. Yeah, that does the trick. T equals 12. Then that gives us 1, 2, 3, 4, 6, right? Yeah, so that gives us 1, 2, 3, 4, 6, and so that is 5 factors within 1 to 10, right? And so the sum of the digits of t is 1 plus 2, so the answer is B. Number 17, distinct points P, Q, R, S lie in the circle x squared plus y squared equals 25 and have integer coordinates. The distances P, Q, and RS are irrational numbers. What is the greatest possible value of the ratio PQ over RS? Right, so let's draw a diagram of this. Right, so this is the circle x squared plus y squared equals 25, and other than the points 5, like these corner points, -5 and -5, the only integer coordinates that we have are over here and over here and over here and over here. It's 4, 3, 3, 4, and -3, 4. No, -4, 3, -4, 3, and then -3, 4, and this is -3, -4, -4, -3, and then so on, right? And so what is the greatest possible value of PQ over RS, right? But then the distances PQ and RS have to be irrational numbers, and so and so this distance, so the so the diameter, that can't be PQ or RS, right? And so the greatest and so the greatest possible value of PQ over RS, that would be when PQ are in these points and they are connected like that, right? Because that would make the because that would make it this length is 7 and this length is 7, so it's 7 root 2, right? And so PQ would be 7 root 2, and RS, that would be that would be obviously these smallest distance, right? And so that would be just, this is 1, 1, so it's just root 2. So RS equals root 2. So PQ over RS equals 7 root 2 over root 2. This is 7. So the answer is D. Number 18, Amelia has a coin that lands heads with probability 1 over 3, and Blaine has a coin that lands on heads with probability 2 over 5. Amelia and Blaine alternately toss their coins until someone gets ahead. The first one to get ahead wins. All coin tosses are independent. Amelia goes first. The probability that Amelia wins is P over Q, where P and Q are relatively prime positive integers. What is Q minus P? Okay, so Amelia winning, this is Amelia winning at the first round, or Amelia not winning, and then Blaine not winning, and then Amelia winning, and then or Amelia not winning, Blaine not winning, Amelia not winning, Blaine not winning, and Amelia winning, like that, right? And so if we put those into numbers, and then getting ahead wins, right? And so if Amelia wins at the first time, that would be 1 over 3, or Blaine could or Amelia could not get ahead, right? 2 over 3, and then Blaine could not get ahead, 3 over 5, and then Amelia could get ahead, 1 over 3, right? Or Amelia could not get ahead, Blaine could not get ahead, Amelia could not get ahead, Blaine could not get ahead, and finally Amelia would get ahead, right? And so this will just continue on, and if you group these numbers into like this, right, that shows that as we go, we are multiplying by this much. And so for us to get the probability that Amelia wins, we have to add all of these up, right? And so that would just be 1 over 3 is the common factor, right? So it's 1 over 3 plus, so it's 1 over 3 times 1 plus this much. This is, these cancel, so it's 2 over 5 plus 2 over 5 squared plus all the way to like 2 over 5 to like the infinitieth power, right? And so this is a geometric sequence. And so the sum is a over 1 minus r, and so since r is 2 over 5, it's 1 minus 2 over 5, and then all under the first one is a, right? So this is 1. So this is 5 over 3, right? And so and so the probability that Amelia wins is 1/3 times 5 over 3, so it's 5 over 9, right? So this is probability of Amelia winning, and so this is P over Q, right? And so P is 5 and Q is 9. What is Q minus P? This is 9 minus 5, so the answer is 4, it's D. Number 19, Alice refuses to sit next to either Bob or Carla. Derek refuses to sit next to Eric. How many ways are there for the 5 of them to sit in a row of 5 chairs under these conditions? Okay, so Alice can't sit next to Bob or Carla, and Derek can't sit next to Eric, right? So we have 5 seats, right? And we can have 3 different possibilities. The first is when Alice is in the middle, and the second is when Alice is in the second or the fourth, and they're the same thing, so we just multiply by 2. And the last is when Alice is at the very end. This is the same as here, so we just all multiply by 2, that again, right? And so first case, when this happens, then Bob or Carla would sit like this, right? That will be the only way. And Derek and Eric would sit like here, right? And these two can change, and these two can change, so this gives us 4. 2 times 2, which is 4. And for this one, Bob and Carla can sit here with like these two, or no, actually Alice can't sit next to Bob or Carla, right? So Bob and Carla can only sit like this, right? And then Derek and Eric will be forced to sit like this, right? And so that is the same thing, but then we have this multiplied by 2, so we have to do just 2 times 2 to that. And for this last one, we have Bob and Carla can be either here, or they can be here, right? And so there are 2 ways of this happening. And then Bob and Carla can change places. And then Derek and Eric should be in the remaining 2 places, but they can also change places, right? So this is also times 2, and so this would be 4, this would be 8, this would be 16, right? So 4 plus 8 plus 16, this is 28. The answer is C. Number 20, let Sn equal the sum of the digits of positive integer n. For example, S1507 equals 13. For a particular positive integer n, Sn equals 1274. Which of the following could be the value of S times n plus 1, right? And so S1507 equals 13. This means 1 plus 5 plus 0 plus 7, that's 13. And so that is what S means. And so if Sn equals 1274, our kind of instinctive reaction is that Sn plus 1, oh, this would be 1275, right? Because then just the ones digit would have increased by 1, right? But then there are other things that can change this value, right? And that would be when something is added, and then that is added to a 9, right? Let's say we have 39, right? And so this would be 3 plus 9, but then if we add 1, then this would be gone. That would be 0. And 3 would have 1 more, so it's 1 plus 3 plus 9, but then the 9 is gone, so minus 9, right? And if we try with something like 5999, then if we add 1 to that, that will be 6,000, and then no, that will be 6,000, because that will be 5 0 0 0 and then 1 more, right? And so this is 1 plus 5 plus 9 plus 9 plus 9, and then minus 3 times 9, right? And so from these, we can see that Sn plus 1, that can also be equal to Sn plus 1 is equal to Sn. Sn plus can also be equal to Sn plus 1, and then minus 9 times any number. Let's say it's A, right? And so this is also plausible, right? And so now we have to find which of these values are Sn is 1274, so 1275 minus a multiple of 9, right? So which of these values are 1275 minus a multiple of 9? So first 1265, this is 1275 minus 10, so that's not it. And 1239, that is 1275 minus 36. So minus 36, and 36 is indeed a multiple of 9. So 1239 can be a value of Sn plus 1. So the answer is D. Problem number 21. A square with side length x is inscribed in a right triangle with sides of length 3, 4, and 5 so that one vertex of the square coincides with the right angle vertex of the triangle. A square with side length y is inscribed in another right triangle with sides of length 3, 4, and 5 so that one side of the square lies on the hypotenuse of the triangle. What is x over y? Okay, so let me just draw these x and y squares in these right triangles. So that would be x, and so that would be the triangles, right? And the side length values are 5, 4, 3. Same for here, 5, 4, and 3, right? But then these ratios, this 3 to 4 to 5 is also 3 to 4 to 5, also 3 to 4 to 5, right? And this is 3 to 4 to 5, and that ratio also applies to 3 to 4 5, and that also applies to 3, 4, 5, and 3, 4, 5, right? And so we can use this ratio to get the values of the hypotenuse, right? And so first, let's go for x. If this is x, then this would be 5 over 3x, right? Because then the ratio would be 3 to 5. So that's 5 over 3x. And if this is x, then this would be 5 over 4x, because that way the ratio would be 4 to 5, right? And similarly, for this one, this is 3 to 4, so that means this length is 4 over 3y. And since this is 4 to 3, right? And so this can be 3 over 4y, right? And so for the green ones, 5 over 3x, 5 over 3x plus 5 over 4x equals 5. So 1 over 3x plus 1 over 4x equals 1, right? And so 4x plus 3x equals 1 times 20, no, 1 times 12, so it's 12. So 7x equals 12, x equals 12 over 7, right? And so x equals 12 over 7, and we'll move this up. And our orange one, that gives us the values that 4 over 3y plus 3 over 4y equals 5. And so all over 12, then that would be 16 plus 12 plus 9 times y would be 5. And so that would be 28 plus 5. So it's 37. 37 y equals 12 times 5, which is 60, right? And so y equals 60 over 37. So y equals 60 over 37. So let me put that up there also. And so what we need is x over y, right? And so x over y is 12 over 7 over 60 over 37. And so this equals 12 times 37 over 7 times 60. And these become 5. So it's 7 times 5 is 35. And the numerator is 37. The answer is 37 over 35, which is D. Problem number 22. Sides AB and AC of equilateral triangle ABC are tangent to a circle at points B and C respectively. What fraction of the area of triangle ABC lies outside the circle? Okay, so we have so let's draw this first. This would be the diagram, right? And so what fraction of the area of ABC lies outside the circle? So what we want is this area over this area, right? And since it asked for a fraction, then we can just input any random numbers and just get the ratio to be right? And so let's say that the radius is root 3, right? Then AB would be 3, and let's say this is O, then AO would be 2 root 3, right? And so ABC is an equilateral triangle. So ABC, first let's do that. This is root 3 over 4 times 3 squared. This is 9 root 3 over 4, right? And what fraction of ABC lies outside the circle? And so now what we need to get is this, right? And that is this whole thing minus this fan, right? And this fan is 1/3 of the circle, right? So what we need to do is this area minus 1/3 of the circle. So let's do that. First, this area, that is just 2 times ABO, right? And just 2 times ABO equals just 3 times root 3. So 3 times root 3. So this is ABOC. Let's write that down first. ABOC. This is 3 times root 3. This is 3 root 3, of course. And and the fan BOC, that would be 1/3 of the whole circle, which is pi root 3 squared. And so root 3 squared is, of course, 3. And so this is pi, right? And so what we need to do is 3 root 3 minus pi, 3 root 3 minus pi. And what we get is this over this, right? And so 3 root 3 minus pi over 9 root 3 over 4, right? And so this equals all over 9 root 3, and then 12 root 3 minus 4 pi. And so if we split that like that, this is, let's move this up here, let's move this up here, right? Then that will be, this will become 4 over 3, and then minus this will become 4 pi over 9 root 3. And if we multiply root 3 to both numerator and denominator, that will be 4 root 3 pi over 27. So this is answer choice E. It's E. Number 23. How many triangles with positive area all have their vertices at points I, j in the coordinate plane where I and j are integers between 1 and 5 inclusive? So we have all of our points at right here, right? And so the leftmost, this one, that would be 1, 1, and this would be 5, 5, right? Because I and j are integers between 1 and 5. And so what we have to do is, there are 25 points in total, right? And so we have to do 25, choose 3, because that is the total number of there are different kinds of overlaps. There is where so there's a kind where one line is over five points, right? Like this one. Or there could be one line over 4 points, right? Like this one. And there could be one line over 3 points, like this one, right? If those 3 were to be chosen, that would not be a triangle with positive area, right? And so we have to find how many of each are in this triangle, in that grid of points, and then we can get our answer, right? So first, let's see the number of lines with 5 points in it. So those would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then that would also be 5, so that's 11, and this is also the same, so it's 12. So we have 12 lines with 5 points on them. 12. And for the 4 points, that's this one, this one, this one, and this one, and there are no more, so that's just 4. And for the 3 points, there's this one, this one, this one, this one, so that's 4. Plus the ones that I talked about before, these ones, 1, 2, 3, 4, 5, 6, and then so that's another 6, and then we can have stuff like the other way around, so like this, 2, 3, 4, 5, 6, right? And so that would be our last 6. And so this is 16, right? So we have 12 5-pointers, we have 4 4-pointers, and we have 16 3-pointers, right? And so since we have 12 lines with 5 points each, then this means that the number of 3-point combinations that cannot be triangles with positive area, they are 12 times 5 choose 3, right? So this is 12 times 5 choose 2, so this is 12 times 10. So this is 120. And for this one, this is 4 times 4 choose 3, right? Because there's 4, and then you have to choose 3 from the 4 points. So this is 4 times 4, this is 16. And this this is 16 times 16, no, 16 times 3, choose 3, because we have 3 points, and we have to choose 3 of them, so that's basically just 1, right? So this is 16. And so the total number of overlaps, this is 120 plus 16 plus 16, which are 152, right? And so yeah, and so now all we have to do is 25 choose 3 minus 152, and 25 choose 3, this equals 2300, and that was an answer choice to distract you, but it's not, and you should be distracted, right? And so the answer is 2300 minus 152, and this is 2148, so the answer is B. Number 24. For certain real numbers a, b, and c, the polynomial gx equals this has 3 distinct roots, and each root of gx is also a root of the polynomial this. And what is f1, right? And so since it's said that each root of gx is also a root of this polynomial, that means gx is actually part of this polynomial. So this is gx times x plus something, right? And so let's try to get what that something is. So this is gx, x cubed plus ax squared plus x plus 10 times x plus something, right? But then one thing that we know is this, right? So so the coefficient of x is 100, and that can't be touched by the unknown value a because it's just the coefficient of 1x, right? And so that will give us that 10x plus something x equals 100x, and so this unknown value, this will be 90, right? So this will be 90, and then we have c, right? Because c equals 10 times 90, which is 900, and so c equals 900, and by that we can get a, and we can by that we can get b, and we can get a, right? And so next we use this thing, x cubed, right? So x cubed, so the power of x cubed 1 equals 1 equals, and then it should be this plus this, right? So it's 90 plus a, so a would equal 1 minus 90, which is negative 89. So a equals negative 89. A equals negative 89, and I'll write that here, negative 89, right? And then yes, and if we have that, that's all we need, because what we wanted is f1, and this is also fx, right? This is also fx. So we can get f1 if we plug 1 into each of these values, right? So the answer is going to be 1 cubed, which is 1, and then minus 89 1 squared, which is 1, and then plus 1 plus 10 times 1 plus 90, that's 91. And so this is 12 minus 89, which is negative 77. That's negative 77 times 91, right? And you could calculate this if you want, but actually, since we have the answer choices, we don't have to calculate this. And because you see, the first digits of both multiplied, this gives 7. So that means the so that means that the units digit of the answer is also going to be 7. And the only answer choice with the units digit of 7 is C. So the answer is C. Our last problem, number 25. How many integers between 100 and 999 inclusive have the property that some permutation of its digits is a multiple of 11 between 100 and 999? For example, both 121 and 211 have this property. Okay, so first let's see the number of multiples of 11 that comes between 100 and 999, and so this is from 110 to 990. And so this is 880 divided by 11, which is 80. So there are 80 multiples of 11. So there are 80 multiples of 11, right? And next we have to look at what configurations of like numbers would make an integer be between 100 and 999, right? And so we have 4 cases for that. 4 cases, and it's when we have something like AA0, right? Like 110 or 220, right? Or we can have ABA, like 121, 242, like 484, stuff like that, right? Or we can have A0B, like 308, that's a multiple of 11, right? Or like 209. And lastly, we have ABC, right? And that could be something like 134, right? No, sorry, 132, right? And so those are the 4 cases for multiples of 11, right? And so first, let's take care of the AA0 cases. For this one, we have 110, 220, 330, 440, and all the way to 990, right? These are 9 cases. And since AA0 can only be manipulated to be AA0 or A0A, this is times 2, so this will be 18. So this will be 18. And for ABA, that would be 121, 484, no, 121, 242, 363, 484, or 616, 737, 858, 979, and that's all we have. So we have 8 cases, right? But then this time we can have AAB, ABA, or BAA, right? And so those are 3 cases, so multiplied by 3, that is 24. And for A0B, we can have 209, 407, 605, or 803, right? Because these two just have to add up to 11, and they can just be the opposite way around. 308, 506, 704, and 902, right? And so that's also 8 cases. But then this time it can be A0B, B0A, or AB0, BA0, right? So there are 4 cases. No, so that is 8 cases times 4. No, sorry, this is not 8 cases, right? Because this and this are equal. This and this are equal. This and this are equal. This and this are equal, right? And so we have 8 cases divided by 2. 8 cases, but we have to do divided by 2, right? Because half of it is the same as the other half. And then we have to do multiply by 4, right? And then we have to do multiply by 4, which is 8 times 2, which is 16. And then lastly, we have ABC, but then we don't want to calculate this after we've done all this, right? And so first, and then we use the knowledge that the total number of multiples of 11 is 80, right? And so we had 80, we had 80 in total, but then we got 9 taken away from us, and we got 8 taken away from us, right? And we got 8 taken away from us. This is not divided by 2 because these and these both count as separate multiples of 11. So that would be 8. And so that would give us 56, right? And out of these 56, ABC and CBA, they would both be multiples of 11. So we have to do divided by 2, just like A0B, right? And for ABC, we have 3 factorial numbers, which is 6 ways. And so this will be multiplied by 6. And this is 56 times 3, which is 168, right? So that's 168. And so 18 plus 24 plus 16 plus 168. If you add them up, this then this is 40. This is 58. 58 plus 168, so it's 226. So the answer is 226. And that's the answer. The answer is A. So that was it for the 2017 AMC 10A, and thank you for watching.